Okay, in this section, we're going to continue to take a look at some exact values of the circular functions. So I'm going to show you some special triangles that are going to help you to be able to work these out. So the first one is if we started with an equilateral triangle, that means each of the angles is 60 degrees, or in radians, pi over 3 radians. Now, if that triangle had a side length of 2, that means all of the sides would be 2. And then what I'm going to do is I'm going to cut this triangle in half so that I've got a right-angled triangle. So here's my right-angled triangle here. So this means in that, just that half of that triangle, this means that this angle here is now 30 degrees, or pi over 6 radians. And the length of this side here is 1. This is obviously still 2. And then using Pythagoras' theorem, I can work out the length of this side, which turns out to be root 3. Okay, so now just using that right angle triangle, I'm actually going to just redraw it out here so that we can see it a bit clearer. Okay, we can work out some exact values of sine, cos, and tan. So let's start with this angle here, pi over 6. The sine of pi over 6 is going to be equal to the opposite over the hypotenuse, or a half, 1 over 2. The cos of pi over 6 is going to be equal to the adjacent, which is root 3 over the hypotenuse, so root 3 over 2. And the tan of pi over 6 is going to be equal to the opposite over the adjacent, 1 over root 3. Okay, we often will rationalize this, so multiplying the top and the bottom by root 3 over root 3, we get that the tan of pi over 6 is equal to root 3 over 3. If we do the same thing for this angle down here, pi over 3, we get that the sine of pi over 3 is equal to the opposite, which is root 3 over the hypotenuse, over 2. The cos of pi over 3 is the adjacent over the hypotenuse, or a half. And the tan of pi over 3 is equal to the opposite, root 3 over the adjacent, which is 1. So just root 3. Okay, so there are some exact values for sine, cos, and tan of pi over 6 and pi over 3. Now we're going to look at a second special triangle, and this is going to be an isosceles triangle, an isosceles right triangle. So that means that each of these angles here would have to be 45 degrees, or pi over 4 radians. Okay, and if we said the length of each of those sides was 1, then by Pythagoras' theorem, the length of the hypotenuse would have to be root 2. And so using this triangle, I can work out exact values when theta is equal to pi over 4. So the sine of pi over 4 is going to be equal to, and you can use either angle here, so the sine of pi over 4 is going to be equal to the opposite over the hypotenuse, or 1 over root 2. If I rationalize that, that becomes root 2 over 2. The cos of pi over 4 is the adjacent over the hypotenuse. It's also 1 over root 2, or root 2 over 2. And the tan of pi over 4 is equal to the opposite over the adjacent, which is just 1. Okay, so there are some exact values there. So in this table here, I've just written down a summary of some of the exact values we've done in this video and in previous ones. So previously we looked at theta when theta is 0, the sine of 0 is 0, the cos of 0 is 1, and the tan of 0 is 0. Here are the angles that we just did here. And we've also looked at what happens when theta is 90 degrees. So the sine of 90 is 1, the cos of 90 is 0, and the tan of 90 is, of course, undefined. So these are the type of questions that you'd be expected to do without a calculator, using these angles here that you know, and then your knowledge of symmetry of the trig ratios that we did in the previous videos. Okay, so let's take a look at some examples. So if we look at the sine of 240 degrees, so if I just draw where the sine of 240 degrees is, that's going to be right in here. Okay, and that means that this little angle is 60 degrees, 180 plus 60. So sine of 240 is the same as the sine of 180 plus 60. Okay, and I can draw the equivalent acute angle here. Okay, now from my cast rule, I know that when sine is 240 degrees, it is going to be negative. So that means the sine of 240 degrees is the same as the negative sine of 60 degrees. And from what I've just done in the previous examples, I know that the sine of 60 degrees is root 3 over 2. So that means this is negative root 3 over 2. Okay, so the sine of 240 degrees is equal to negative root 3 over 2. Let's look at the same thing with tangent. So here we've got the angle 7 pi over 4, and you're going to have to become pretty good at fractions when we're working with radians. So 7 pi over 4 is the same as the tan of 2 pi minus a quarter pi. Okay, so it's actually this angle down here. So this whole thing would be 7 pi over 4. Or we can say that this angle here is pi over 4. Okay, and using the cast rule, I know that in this quadrant, tangent is going to be negative. Okay, so the tan of 7 pi over 4 is equal to the negative tan of pi over 4. Okay, tan of pi over 4, if I look up here, is 1. So the tan of 7 pi over 4 is negative 1. Okay guys, so you can now have a go at exercise 16F.